Elasticity. A fried chicken franchise finds that the demand equation for its new roast chicken product, roaster, is given by the formula P equals 40 divided by Q raised to the power 1.5, where P is the price in dollars per quarter chicken servings, and Q is the number of quarter chicken servings that can be sold per hour at that price. Express Q as a function of P and find the price elasticity of demand when the price is set at $4 per serving. Interpret the result. Now, the price elasticity of demand is given by the equation E equals negative dq dp times P over Q, where the negative sign is part of the formula. dq dp is the derivative of Q with respect to P, which means we will take the function Q and differentiate it with respect to P. However, the formula is given as P equals, or price in terms of the quantity. What we need is Q equals so that we can take the derivative. And that is why we would need to express the given equation P equals 40 over Q to the power 1.5 in terms of P. Q equals something. P is P over 1. Cross multiply, we will get P times Q to the 1.5 power equals 40 times 1, which is 40. Then we isolate Q, but we cannot do that yet. We need to isolate Q to the power 1.5 by itself. So Q to the power 1.5 is 40 over P, but 1.5 is the same as the fraction 3/2, so we rewrite this as Q to the 3/2 equals 40 over P. Now, to get Q by itself, we rate both sides of the equation to the power 2/3. And if we do that, then on the left-hand side, the power 3/2 times 2/3 is 1, leaving us with Q to the 1 power, or Q. And the right-hand side is 40 to the 2/3 power over P to the 2/3 power. And this is now Q as a function of P. Having Q as a function of P, to find the elasticity, we would need to differentiate the function Q with respect to P. And to do that, we rewrite this as Q equals the constant 42 over 3 constant multiple times P to the negative 2 over 3, where we bring the positive power to the numerator and make it negative. dq dp is therefore 40 to the power 2/3 is a constant multiple, so we would rewrite it. The derivative of P to the negative 2/3 using the power rule, we bring down the power negative 2/3 P, and we lower the power by 1. Negative 2/3 minus 1 is negative 2/3 minus 3 over 3, so we get the power negative 5 over 3. If we were to rewrite it, then we'll get dq dp equals negative 2/3 times 40 to the power 2/3 over P. We bring it down to the denominator to make the positive power 5/3. The elasticity is negative sign. dq dp is now negative 2/3 times 40 to the power 2/3 over P to the power 5/3 times P divided by Q. But Q by itself is 40 to the 2/3 divided by P to the power 2/3. Simplifying this, because this looks awfully complicated, negative times negative is positive, so we get 2/3 times 40 to the power 2/3 over P to the power 5/3. And with this complex fraction, we get P divided by a fraction. It is the same as P times its reciprocal. So P times P 2/3 over 40 to the power 2/3. The first thing we notice is that we can cross out this 40 to the power 2/3 top and bottom, and we get 2/3 times P to the power 1 times P to the power 2/3. 1 plus 2/3 is 3/3 plus 2/3, which is 5/3. And in the denominator, we still have P to the 5/3, and this cancels out as well. So the elasticity is 2/3, or approximately 0.67, rounded to 2 decimal places. The price elasticity of demand is less than 1 in this case, so we would say the demand is inelastic. This means we can obtain better, we can maximize the revenue if we increase the price. Now, the question actually asks us for the price elasticity of demand when the price is set at $4. However, the elasticity that we found is a constant. In function notation, we can write E of P. This is not E times P, but E of P is a function equal to 2/3. And so if we plugged in 4 into this function, we will get 2/3. And again, this elasticity is less than 1, so we would say that the demand is inelastic, meaning we can obtain better revenue by increasing the price.